Yeah, I'm in the middle of filming an episode right now. You call it teaching, I call it an episode. It's like a TV show for the students.
Now we're on School G, every single grade, and that's the story of the evolution of Wade.
All right, welcome back to pretty much Mr. Wade's virtual television show here on how to do BC Calculus. Quick review though. If y equals 5x, what is y prime? This is not on the paper, you don't have to write it down, just remember, what is the derivative of 5x? 5x, the 1 comes down, and you get 5x to the 0, which is just 5, right? If y equals 7x, what's y prime? 7. If y equals 1x, what's y prime? 1. So you always get the coefficient, right? Okay. Remember this for the future because we're going to do those derivatives a whole lot, all right? Now, what was the very first derivative we ever did together? Y equals 4x cubed was the beginning of lesson 1-1. Remember that? How do you take the derivative of... All right, what's the derivative of 4x cubed? I lost my marker. All right, got the marker. What's the derivative of 4x cubed? The first one we did together. 3 times 4 is 12. Base x stays the same. Drop it by 1, okay? So I want you today to remember basic derivatives, and then I want you to remember the super basic derivatives. Number x just becomes number. Keep that in mind. Example A, y equals coefficient 3, 2x cubed plus 5 quantity to the 10th. All right, we've talked about number, base, power. We just did 4x cubed on the other board. Number, base, power. Okay, what's the rule? All right, y prime equals, or fancy version, dy over dx equals. Okay, 10 comes down to the front, hits the 3, multiplies that. 10 times 3 is 30. What do we always say about the base? The base stays the same. Remember this, base stays the same. What happens to the power? Subtract 1. 10 drops to 9. Now so far that's all we've done in BC. Power comes down, base stays the same, drop the power by 1. There's a new twist today. Times something else. So the big question is, what in the world goes here? All right. This is called the chain rule. All right, so we have to put in this parentheses what is called the chain. Now, what is the chain and why is it recommended all of a sudden when we didn't talk about it before? Okay, the chain rule is the derivative of the original base. So jot that down. That's very, very important. Let me tell you how important this is. In my opinion, it's the most important specific rule in all of mathematics because every single derivative actually has a chain rule. Every single one of them, okay? So the derivative of the original base. Let's go back. Remember 2x cubed plus 5? That was the original base. 3 is not part of the base. What did we do with the base? Didn't we keep the base the same because that's part of the rule? But did we ever send 2x cubed plus 5 through the derivative process? Did it ever actually have the derivative taken? No, it just stayed the same like it was supposed to. But eventually, you must address the original 2x cubed plus 5, okay? So let's go back to the original base, and I want to take the derivative of 2x cubed plus 5 like we did in lesson 1-1. This is like the easiest derivative right here. And then we're going to insert it right there. And that's called the chain that links to the rest of this chain right here. Okay? It's the chain of the chain rule. So just focusing on this. Don't look at 3, don't look at 10. Just focus on 2x cubed plus 5. What is the derivative of 2x cubed plus 5? Heck, you could do it over here to the side if you want. We used to do this sometimes with complex problems in integrated 3. We call it the aside because the college professors call it that. If you had to take the derivative of just this base, wouldn't you just bring the 3 down? 3 times 2 is 6. The base is x, which stays the same. 3 drops to 2. 2. I don't know why my voice did that. Anyway, what's the derivative of 5? What's the derivative of any constant? 0. You can put it plus 0 for your notes, so when you look back, you remember what you did. But I mean, why? In the future, like on the test, don't worry about it. So the derivative of 2x cubed plus 5 is 6x squared. That is the chain rule. We're going to insert it right back into the problem. So 6x squared goes right here. All right? And so now we have a new twist, and you're going to use this all throughout the year. Every derivative has a chain. Now you got to be thinking, wait a minute, Mr. Wade, the chain rule is in every derivative? You just taught us 1-1 and 1-2, and you made no mention of the chain rule. But it's supposedly in every derivative. It is. First derivative we took this year, 4x cubed, right? Here's what secretly happened that you didn't have to worry about yet, that you now have to think about, okay? When the 3 came down, right? 3 comes down, 3 times 4 is 12. What's the base? Is the base 4x or is the base x? Who's going to the third power? That 4 is not going to the third power unless I write 4x quantity cubed, but it was not that, was it? Only x is being cubed. The base is x. The base, we'll even put it in parentheses, the base shall stay the same, x. The power shall drop by 1. What did I not mention in 1-1 and 1-2 that now matters? What was the original base? X. The chain rule says take the derivative of the original base and stick it at the end by multiplication. What is the derivative of x? Remember our review? Derivative of x is 1. So the chain rule or derivative of the original base is times 1. That's why we didn't put it. Every problem I gave you, intentionally, this is what calculus teachers do. On 1-1 and 1-2, every problem had base x. Today we have more complicated bases, 2x cubed plus 5. But so far I've only given you base x. And what's the derivative of x? 1. So after every single term, in every derivative we've done so far, there was like an invisible times 1, times 1, times 1, times 1, every time. You didn't see it. You didn't have to worry about it. Starting today, you got to think about it, okay? So, chain rule, very important. We had times 1 before. I never mentioned it. Now we have more complicated. All right, so hopefully you're seeing that the chain rule was hidden before. Now you see it. And let's write a final answer right here. There is something I would like for you to do. That's not a bad answer right there at all. But I see a single term known as a monomial, and I see a single term known as a monomial. And this is all just multiplication. 30 times a quantity times 6x squared. If it's all multiplication, you remember even in middle school, the commutative property, you can switch things around. If I switch this 6x squared up to the front, couldn't it just combine and multiply into the 30? So you should do that. By leaving this answer, you're saying, I don't know what 30 times 6 is. Of course you do. Go ahead and simplify that. 30 times 6, our old favorite game from integrated class called Hide the Zero. That's just 3 times 6, which is 18. So it's 180. Bring the x squared along with you. And then this quantity will just stay exactly the same. And that goes there, okay? So you want to combine any sort of monomials like that, okay? Final answer. All right, letter B, radical, get rid of that radical. Let's rewrite this. 7 parentheses, who's the base? X squared plus 3x plus 7. All right. Cube root, roots on the bottom. It's to the something thirds power. 1/3, 2/3, 3/3, 4/3. How many thirds? What is the exponent. The root is 3. What's the power? There is no power, is there? Don't use that squared on the x. That's not the power. We're talking about the quantity power. If there is no power, isn't that whole base technically going to the first power? Because everything in the world is going to the first power secretly. So all that's to the first. The power is 1, the root is 3, it's to the 1/3 power, okay? I want you calculus students to get really good at just looking at a cube root and knowing that a cube root without any extra powers, cube root is always 1/3, okay? Square root is always 1/2. Fourth root is always 1/4, okay? So, we got that. We are ready to take the derivative because we have number, base, power, which is exactly what we want, number, base, power. All right, let's take the derivative. Y prime equals 1/3, comes down, multiplies the 7. Base does what? Base always stays the same, right? All right, what happens to the exponent? Subtract 1. 1/3 minus 1. Okay, I guess I'll just walk away and leave it like this. I guess I'll just go over to my podium of bad ideas. Wait, Mr. Wade, wait, Mr. Wade. Remember integrated 3, we used to do that all the time? So, no, you're not done. In 1-1 and 1-2, you could get away with just doing power comes down, base stays the same, drop it by 1. But remember, every derivative has a chain rule, and the bases are more complicated today. So, base stays the same, drop it by 1 times, get in the habit of multiplying by the chain rule. Okay, what's the chain rule? The derivative of the original base. You could see it here better probably. It's also under the radical. That's your original base. Take the derivative of x squared plus 3x plus 7. Okay, if you only have x squared plus 3x plus 7 and that's it, wouldn't the derivative be 2x to the first? What do we call that? 2x? And then the derivative of plus 3x, isn't that just plus 3, right? And isn't the derivative of 7, since it's a constant, 0? So it's just 2x plus 3, okay? That's just a day 1, lesson 1-1 derivative is what that is. Okay, keep it simple. All right, now let's see if we can simplify anything here at all. All right, well, first of all, 7 times 1/3, we got to fix that, right? Isn't that 7 over 1? Okay. In the future, I'd rather you not put the over 1 and get really good at this calculus kind of stuff and algebra. But if you need it again for a security blanket, you can put over 1. Isn't that just 7 times 1 and 1 times 3 and there's no cross cancellation? So 7/3, done. Base stays the same. X squared plus 3x plus 7. 1/3 minus 1. Oops, we don't have a common denominator. But wait a minute. I can disguise 1 as 3 out of 3. So 1 minus 3 is negative 2 over the common denominator of 3 times the chain, which is 2x plus 3. All right? Now we're ready. Now in the future, calculus students, my BCers, you're the best of the best. In the future, if you could just bring the 1/3 down and already know that that's 7/3, you won't have a wasted step. And if you can just do in your head 1/3 minus 1 is negative 2/3, which you all will be able to do, I promise you. You'll all just look at 1/3, subtract 3/3, negative 2/3. We want it quick, all right? So in the future, we won't spend this wasted step. We'll already be here, and we can keep going. Now, how do you simplify that? And what's wrong anyway? Well, Mr. Wade, you probably all noticed this. There's a negative exponent. You can't leave negative exponents in math. All right, so here's what we need. My final answer is going to have one long fraction bar. You've got to figure out for yourself who's on the top and who's on the bottom, okay? 7, numerator or denominator? Clearly the numerator. 3, clearly the denominator. Okay, wait just 1 second on this one. 2x plus 3, don't necessarily put this, but you should just know in your head that's over 1. Everything's over 1. So that is technically on the top or numerator with the 7. Oops, stray mark. Okay, all right. Now, what to do with this one right here? Okay, is it on the top or on the bottom? First of all, it's over 1, right? Second of all, it's on the side of this fraction. Side means top. It's really with the 7 right now. It just looks better on the side for calculus. But it's up there with the 7. It is over 1. So this is currently on the top, but the negative power says I'm going to move you to the bottom. So in the denominator, we write this now to the positive 2/3. Okay? And that's a good answer right there. That's a full credit answer. All right, 2 things to talk about. All right, so number 1, in the last problem, didn't we have a monomial and a monomial, right? We had the 30, and then we had the times 6x squared, and they were single monomials, and we put them together. 7 is a monomial, technically, 7x to the 0. 2x plus 3 is clearly a binomial. If it's monomial, binomial, you do not have to combine those. Matter of fact, I think it's a disadvantage in calculus to distribute the 7 into that parentheses. You can distribute. Nobody put a lock on the gate, as we used to say in integrated class. There's no power on the parentheses. So you can distribute the 7 if you want to. It's better to just leave it monomial, binomial. Now, if it's 7 times 2x, you better multiply those. So top, leave it. Bottom, it's okay, but isn't the 2/3 power exponent form? Didn't we start in radical form? So for my best students, let's change that from exponent form to radical form. All right, what's the root? Still 3rd root. Okay, let's put a cube root, make it nice and long here because we're going to have to fit a lot of stuff. What's the 2? 2 is the power. Oops, I just completely missed that one. 2 is the power. It's quantity squared. So x squared plus 3x plus 7 quantity squared. And that is the same thing as the 2/3 power, but it went back to radical form, which is better. And then just fill in the rest of it. What do we have? A 3. And we got a 7. And we've got a 2x plus 3. And there's no need to distribute, and later you will not want to distribute for sure, because you'll want this to be in what I would call factored form. It's all nice and factored and very efficient, okay? All right, so the letter C, f of x equals 3 over 4 square root of 3x plus 5. Okay, first, radicals, don't want them, right? Not for now. Radicals are important, but they don't help us in derivatives. So 3 over 4, parentheses, the base is 3x plus 5. We were just talking about this. Square root means 1/2 power. You shouldn't even think about it, just instantly, instincts. Okay, 1/2 power, you know that one. All right, oh, there's a double whammy this time. Letter B, we changed the radical to exponent form. Letter C, we changed to exponent form, but the x is still on the bottom. We don't want the x on the bottom. We want to move it to the top. So, who's on top? 3. Who's on the bottom? 4. Who's the coefficient? 3/4. 3/4 is actually a coefficient here. And then, couldn't we put this on the side? So we put this on the side, which does mean top. So now it's to the negative 1/2 power. Now ask yourself, did I make it easy on myself? Do I have number, base, power? Yes. That means you're ready for the easiest type of derivative, number, base, power. Okay? Remember from our last lesson though, if there had been an x upstairs, x downstairs, you would have to do the quotient rule. The quotient rule, while it does work on this problem, it's a whole lot of extra work. So you would not want to do the quotient rule today, just because it happens to be division, okay? All right, number, base, power. Let's take the derivative. Okay, so what's the derivative notation for f of x? F prime of x, or the super fancy version of that. Here's your fancy notation. D over dx with f of x on the side. Okay, that's the fanciest notation. What is that? That's actually just dy dx, but we replaced y with f of x. Because how many times did we talk about it in integrated class? F of x, y, it's the same thing. So really read that like dy dx kind of. All right, so normally just put this notation. Don't overcomplicate it unless in college they forced you to do this. Okay, the rule is take the exponent, -1/2 comes down, multiplies the 3/4. You can do that in your head, even better. If you want to just take it slow for now, that's fine. So 3/4 times -1/2. What happens to the base when you take a derivative? It always stays the same. What happens to the exponent? You subtract 1. You can do that in your head. That's even better. For now, you can just write -1. All right, I guess that's it. So I guess I'll just walk over here to my podium of bad ideas. No, Mr. Wade, wait a second. Wait a second. Okay, the power came down. The base stayed the same. We dropped the power by 1 times. We just discussed that every single derivative has a chain rule. So we must multiply by the derivative of the original base. I've circled it for you right here. You can see it there and there. You can best see it right here, right before you take the derivative. What is the derivative of just 3x plus 5? We just did that review over there. Look at the 3x first. What's the derivative of 3x? Isn't it just 3? What's the derivative of plus 5? Isn't that plus 0? Or just skip it? That's it. Chain rule 3. You just have to remember to do it. Okay? Now, calculus is done. It's all basic algebra from here. Integrated 1, little integrated 2 maybe. Okay? All right, first thing I see is a couple of fractions. I look for some cross cancellation. Nope, no cross cancellation. I also want to combine this though, because isn't this 3 over 1? So I would like to do this in one step here. By the way, if that 3 and maybe there was like a 9 right here, you also could have cross-canceled those. Because it's times, some kind of quantity, and times. If it's all multiplication, you actually could cross-cancel even that far across the problem. How about that? But again, 3 and 4, 3 and 2, 3 and 4, there's nothing is compatible here. All right, so the top of our fraction, we've got a 3 times -1 times 3. Just cram all the numerators together. Isn't that -9? Boy, that's a sloppy 9. Mr. Wade always has strange 9s, right? On the bottom, 4 times 2 times 1, let's put a long fraction bar, is 8. Okay, so we got the top and the bottom all put together. One last thing, 1 needs to be disguised as 2 out of 2. Now we have a common denominator. So -1/2 minus 2 over 2. -1 minus 2 is -3 over common denominator 2. But then isn't the negative going to make this go to the bottom? So for your final answer, or one possible final answer, I would fully accept -9 is on the top, 8 is on the bottom, and the negative sends this to the bottom for a possible final answer, full credit, -3 over 2 becomes +3 over 2. Okay? Very solid answer right there. Okay? Overachievers, i.e. BC Calculus students, 3 over 2 should go back to radical form. So acceptable. Best answer though, f prime of x is equal to -9 over 8. The 2 is the root, so it's a square root. The 3 is the power, so it's a cube. 3x plus 5 quantity cubed. Get that cubed under the radical there, okay? And that is your best possible answer. And let me look at the monitor. Is it in there? Yeah, just barely. Okay. Wanted to make sure it wasn't cut off. Okay, there you go. All right, letter D. Y equals 7 sine of x cubed plus 1. Does the chain rule apply with the problems we just did? Yes. Does the chain rule apply with trigonometry, sine, cosine, tangent, and eventually cotangent, cosecant, and secant? Yes, of course it does. The chain rule applies to all derivatives. So, y prime, or your fancy version dy dx, your choice. Okay, most people go with the faster version. Coefficient. Okay, let's see. I think we've talked a little bit about this already. Coefficients just stay. They stay right there. Okay? It's just 7 times as much as it would have been if we didn't have that 7 there. Okay? So just keep the coefficients. You know what? I don't write this down, but just as a side note. Even when 3 comes down and multiplies 4 in your most basic derivative, doesn't it become like 12x squared? Isn't 4 the coefficient still in there, right? 4 is in 12. It's just masked by 4 times 3. But the coefficient is always still in there. It's really obvious when you have sine, cosine, tangent, natural log. We'll have some of those, of course, too. So you see the coefficient just sitting right there. Because we're not doing the bring the power down. There's no power in this problem, all right? I mean, not including that one. We're talking like a whole power. So the 7, the coefficient just stays. Don't worry about that. Focus on the sign. What did we say the derivative of sine was in this class? Derivative of sine is cosine. What happens to the base when you take a derivative? The base shall stay the same. All right? Well, I guess I'll go to my podium of bad ideas. No, don't you dare, Mr. Wade. Hold on a second. All the problems I gave you in 1-1 and 1-2 were like sine of x, cosine of x, tangent of x. Simple. That ain't x. That's x cubed plus 1. It's more complicated. All right. Chain rule. Always think chain rule when you take a derivative. What's the derivative of the original base? Because we brought it down to here, but we never sent it through the derivative process. You have to address that eventually. What's the derivative of just x cubed plus 1? 3 down, x to the second. 3x squared. Plus constant becomes plus 0. It's gone. Okay? Don't forget that chain. That is the main focus today. All right. You're pretty much done. I mean, you could almost leave this as an answer. You'd get a -1. So, one little tiny fix. 7 is a coefficient. 3x squared should be part of the coefficient. They should be together. Wait a minute. Last problem. Monomial, binomial don't have to distribute. Monomial, monomial, single terms must combine. 7 times 3, you know what that is? 7 times 3 is 21, and the x squared comes along. And then the trig function should always come last. You shouldn't have a lingering x squared after that. That doesn't look good mathematically. You're done. Okay? All you have to know is just your chain rule derivative. Just do it, and then you'll get all these problems right.